Welcome to Completing the Square by EnergizeMath.com. When you're done this lesson, please visit EnergizeMath.com to download this note. Completing the Square takes a general form or a standard form of a quadratic and converts it into vertex form. There's two main ways we're going to look at it. The first one is when your a value, your first value is 1. It's kind of like a simple trinomial. When you go to do that, you want to convert your trinomial into a perfect square trinomial. In this case, if it was x squared plus 6x plus 9, it would be a perfect square trinomial. So I have this minus 1 here. It's not exactly what I'd like. I'd rather have a 9 there. I want to take my b value, my 6. I'm going to divide it by 2, which equals 3. And then I square the 3 and I get 9. What I'm going to do is I'm going to take that 9 and I'm going to insert it after the 6x. So it's going to go x squared plus 6x plus 9. That is now a perfect square trinomial, but that changed the way the trinomial looks, or what the value is equal to. So I have to add the 9, then I have to subtract the 9 to keep it balanced, and then I still have my minus 1 afterwards. These first three terms, that is your perfect square trinomial. It follows a pattern of a squared, 2ab, b squared. Also, you can way of looking at it is what multiplies to 9 and adds to 6 would be 3 and 3. So I can write this out as being x plus 3 squared, those first three terms. Then I have my minus 9, my minus 1 afterwards, which becomes minus 10. My vertex is negative 3, negative 10. Okay, so I just went from standard form into vertex form. Taking a look at the second example, same method, I want to turn this into a perfect square trinomial. So I'm going to take my b value, which is the 10x, I'll just take the 10 divided by 2, which equals 5. I'm going to square that value, which gives me 25. That tells me what to add and subtract. So I have x squared plus 10x. I want to go plus 25, minus 25, and then I have the minus 3 afterwards. I just inserted that in. The plus and minus doesn't really change the value that your quadratic is. These first three terms, that's your perfect square. A squared, 2ab, b squared. It can be written as x plus 5 squared. You have your minus 25 and your minus 3 afterwards, which becomes minus 28. Again, now you can see clearly what your vertex is. It is negative 5, negative 28. Okay. In the third example, now you'll end up dealing with some decimal places. Take your b value, divide it by 2, which gives you 2.5. Square that 2.5. Which gives you 6.25. Again, add and subtract it. Plus 6.25 minus 6.25. These first three, they are a perfect square trinomial. And they will shrink down. Now, a quick way of realizing what it goes down to is it'll always go down to what half of your initial b value was. So it's going to go down to x plus 2.5 squared. And then you just have your minus 6.25 afterwards. Looking at when your a value does not equal 1. That requires a few additional steps. The first step is you're going to divide your a value away from the first two terms. No matter how it divides, even if it gives you some decimal places, it doesn't divide cleanly, you still divide it away. 3 bracket x squared plus 5x minus 4. I column factored out that 3. Now I'm going to complete the square within the brackets. Take your b value, which is 5, divided by 2, which is 2.5 again. 2.5 squared gives me 6.25. Inside the brackets, 6.25. I add my 6.25 and I subtract my 6.25. Then I still have my subtract 4 afterwards. Again, inside the brackets, I have my perfect square trinomial. It's going to shrink down. It's going to shrink down to what half of the b value was. X plus 2.5 squared. Now I have the minus 6.25 that's still left, but it's inside the brackets. I need to get it outside the brackets by the minus 4. So I'm going to do that by multiplying it by the 3 to get outside the brackets. And that's going to give me negative 18.75. Subtract 4. 3 bracket x plus 2.5 squared minus 22.75. My vertex, again, I can clearly see is negative 2.5, comma, negative 22.75. This is Completing the Square by Energize Math. Please visit energizemath.com to download this note. Thank you very much.